Atomic Physics, Lecture 8, Fine and Hyperfine Splitting of Energies. Topic 1, Fine Splitting of Energy Levels. Paragraph 1, Fine Splitting of Energy Levels. Previously, two effects were considered that lead to a fine splitting of energy levels. These are the relativistic dependence of mass on velocity and spin-orbit interaction. These effects are described by the Dirac equation. Both effects give additional terms to the initial energy levels which have the same order of smallness. That is, two types of terms are added to each energy level, a term due to the relativistic effect and a term due to the spin-orbit interaction. In this case, the relativistic effect splits energy levels according to the values of the orbital momentum, and the spin-orbit interactions according to the spin directions. As a result, the energy turns out to depend on three quantum numbers: the principal, orbital, and spin numbers. It remains degenerate only in the directions of the orbital momentum, that is, in the magnetic quantum number. Thus, each initial energy level turns out to be split due to the relativistic effect into several sublevels, depending on the number of possible values of the orbital momentum. And each of these sublevels splits, in turn, due to spin-orbit interaction, into two more sublevels that differ in the spin direction. Paragraph 2. Experimental observation of energy splitting. The energy levels of an atom are observed experimentally from its spectrum. Each line in the spectrum of an atom corresponds to a transition between two specific energy levels. Accordingly, the splitting of energy levels is observed experimentally as a splitting of spectral lines. The lines in the spectra of atoms with increasing resolution of the spectrograph turn out to consist of several very closely spaced, very thin lines. These lines are called spectral fine structure lines. Each of them corresponds to the transition between two specific levels of fine structure. Paragraph 3. Splitting by magnetic quantum number in the magnetic field. As mentioned above, in the fine splitting of energy levels, only the splitting by magnetic quantum number is missing. However, such splitting is also possible. It occurs in certain physical situations. Namely, degeneracy in the magnetic quantum number can be removed by placing the atom in an external magnetic field. Then the vector of the magnetic orbital moment of the electron will interact with the field strength vector with energy depending on the mutual direction of these vectors. This will lead to the appearance of additional magnetic energy in the electron, depending on the orientation of the magnetic orbital moment, and consequently on the magnetic quantum number. Therefore, in the magnetic field, a term depending on the magnetic quantum number will be added to the initial energy along with other subtle corrections. Consequently, the initial energy level will further split into a magnetic quantum number. In this way, fine energy levels in the magnetic field are further split. Accordingly, each spectral line of the fine structure will additionally split into several lines. Note that corrections to energy due to interaction with an external magnetic field are also considered to be fine corrections in magnitude. That is, they're of the same order of magnitude as other fine corrections. Topic 2. Hyperfine splitting of energies. Paragraph 1. Hyperfine corrections. In addition to fine corrections to energy levels, there are also hyperfine corrections due to taking into account the parameters of the atomic nucleus. Hyperfine corrections split the fine structure levels into several hyperfine levels. These corrections are called hyperfine because their value is much, thousands of times, less than the value of fine corrections. Accordingly, in the spectrum of atoms with increased resolution of the spectroscope, one can see that each fine structure line consists of a set of ultra-closely spaced hyperfine lines, hyperfine structure lines. There are the following two types of hyperfine corrections. 1. Corrections due to the presence of different isotopes in the substance. Different isotopes have different nuclear masses. 2. Corrections due to the presence of spin in the nucleus. As can be seen, both types of corrections are due to the nucleus. Let's look at them briefly. Paragraph 2. Corrections due to the presence of isotopes. The correction associated with the presence of isotopes is due to the following two circumstances. 1. A substance, as a rule, is a mixture of isotopes that differ in nuclear masses. 2. The nucleus is not absolutely motionless, but along with the electron, rotates around their common center of mass. The position of the center of mass of a system depends on the masses of its constituent parts. So for different isotopes, the center of mass is located at slightly different points inside the atom. This results in slightly different Coulomb interaction energies between the nucleus and the electron for different isotopes. Accordingly, each energy level of the fine structure turns out to be slightly different for different isotopes. Therefore, each spectral line of the fine structure of atoms, which are a mixture of isotopes, turns out to be split into several lines of hyperfine structure. In this case, the number of hyperfine structure lines depends on the number of different isotopes in the mixture. Note that this type of hyperfine splitting will not be observed if we conduct an experiment on only one atom or on a set of identical isotopes. Paragraph 3. Corrections due to nuclear spin. Let us now consider the hyperfine splitting of electron energy due to the presence of spin